Very good evening, students. Today we are going to discuss symmetry of molecules. So my name is Dr. Praveen Kumar Yata, OUPG College JOGIPET. So in this lecture, we need to learn the concept of symmetry of molecules. So first of all, the term symmetry is derived from the Greek word symmetria, which means measure together. Symmetry is a kind of balancing act. Symmetry is a phenomenon of natural world as well as the world of human invention. Symmetry is all around us and is a fundamental property of nature. So symmetry refers to beauty of an object, that is a aesthetic concept. Most of the objects in the nature look beautiful because of their symmetry. Symmetry greatly enhances the beauty of the nature. For example, here see some objects of the symmetries and insects and fruits, leaves, things, etc. Animals, flowers, etc. So symmetry animals, butterfly symmetrical, and symmetry is man-made of environment, that is the Charminar, and another man-made object is Lotus Temple symmetry, the Taj Mahal, which is also symmetrical structure, Eiffel Tower in Paris, and Patron's Twin Towers, Malaysia, and our Indian parliaments. So all these objects are look beautiful because of their symmetry. Now let's look into the concept of symmetry of molecule. The term symmetry also refers to the geometry of molecule, that is a scientific concept. All objects, living or non-living, are made up of molecules. These molecules have certain geometrical shapes. The concept of geometry can be discussed in terms of symmetry. The symmetry concept and its related group theory are extremely useful to rationalize and simplify many problems in chemistry. So what are the prediction by using of this symmetry means? It predicts a number of fundamental bonds in IR and Raman. It predicts number of stereoisomers of a given unknown molecules, predicting the type of orbitals involving the bonding. So which orbitals are involved in the bonding, we should know by using of this symmetry. And we can be predict optical activity of molecules, explaining the electronic spectra and molecular orbital theory of metal complexes, it explaining the number of additional properties of molecule, assigning term symbols of d orbitals in a crystal field splitting. A molecular model kit is a very useful to understand the symmetry of molecules. So what is symmetry? It is difficult to answer this question, but one can feel the symmetry in all its possible aspects. It can be rather explained or illustrated as a property of geometrical figures. It can be defined in a user-friendly manner as, so any molecular object is said to be symmetrical if it can take up one or more equivalent configuration by performing some geometrical manipulation on it. For example, water molecule. So in H2O molecule, we have two hydrogens, one oxygen. So shown in picture. So original configuration, when we rotation anti-clockwise 180 degrees rotation, it will give the another geometry, that is equivalent configuration. So 1, 2 are the equivalent configuration. Let us take another example, that is a BX3 type of molecule. So in this BX3 type of molecule, every 120 degrees rotation anti-clockwise will give the one different geometry. So here 1, 2, 3, 4 structures are there. 1, 2, 3 are equivalent configurations, 1, 4 are identical configurations. So in order to understand the symmetry of molecules, one should familiar with symmetry operation and symmetry elements. These two are intricately related, that is one does not exist in the absence of another. So symmetry operations. It is a geometrical manipulation on the molecules. When performed results an equivalent or indistinguishable configuration of the molecule. For example, let us consider the H2O molecule. So in H2O molecule, there are three structures. So every 180 degrees rotation will give the one structure, different structure. 1, 2 are equivalent configurations. 1 3 are identical configuration. There are three symmetrical operations basically. One is a rotational about an axis, reflection in a plane, inversion throughout a plane point. So in order to perform the symmetry operation on a molecule, one should familiar with the following. So there are some coordinates and their structures. So shape of the molecules are to be known. So two coordinated linear either bend structure. Three coordinated molecules will give trigonal planar, T-shaped or trigonal pyramidal. Four coordinated molecule will give the three different type of structures: tetrahedral, dipsahedral, seesaw structure or square planar structure. So five coordinated molecules: trigonal, bipyramidal, square based pyramidal, and pentagonal planar. Six coordinated molecules only octahedral geometry, and seven coordinated molecule will give this pentagonal bipyramidal geometry, and 8 coordinated square antiprismatic geometry. So these are the coordinated and their possible structures. So atoms or groups in the molecules are assumed to be in free state. So center of gravity should not be altered during the symmetry operation. So holding of the molecule in a proper orientation. Symmetry elements in a geometrical entity exist within the molecule. It can be an axis, shows an arrow, it can be a plane, shows on dotted lines, it can be a point in the molecule, and it is degenerated by the corresponding symmetry operation. So in molecule there are 5 types of symmetry elements which can be generated from the 3 types of symmetry operations. Here elements and symmetry operation. So which operation will perform the which element will give generated in this operation? Let us see. So n-fold of rotation will give the rotational axis. It shows notated by the Cn. N is equal to number theta value, number of degrees of rotation, and reflection operation will give the sigma, that is a plane of symmetry, and improper rotation, that is will give the elements of improper rotational axis, that is a Sn, will show the Sn. Rotation followed by reflection we call the improper rotational axis, and inversion operation will give the I, symmetry element is I, that is the center of symmetry, and another identity operation will give the identity element, that is a E. So these are the symmetry operations and symmetry elements. This is a basic concept of symmetry of molecules. We'll take next class to further. Thank you, one and all.